as Tom said, I'm hoping to share with everyone this evening some observations about green buildings, taking us back to where I have picked the idea started, and tracing that idea through to the present time and what's happening around us now, using some examples of our work to illustrate some of these current ideas. And then I'd like to conclude by looking ahead to the future and how exciting I feel the opportunities ahead of us are. So, since I'm giving the talk, I get to pick when we started. And my pick is the publication of the Whole Earth Catalog in 1968 by Stewart Brand. In that publication, I think he was the first one to describe what he called the overview effect, which is that image of the Earth from space, right? Astronomy had always been about taking pictures of planets, including the moon and so forth. So somebody finally, on the way to the moon, had the idea to turn around and take a picture of this beautiful, blue, fragile ball. And that became the thesis behind the overview effect. And the great thing about the Whole Earth Catalog is it didn't stop there. It connected habitation to the environment. And it was just like a do-it-yourself kit of how to inhabit the planet more gently. And I think launched the green building movement at the time. So lots of things happened, some of them crazy. This is one of the craziest things. This is Paolo Soleri, an Italian-American architect who in 1970 proposed the idea of a completely off-the-grid community, a completely self-sufficient city of the future, as he called it, and he named it Arco Santi. You can visit it. There you can see that in the top slide, or the top image on that slide. It was a very heroic attempt, and it's sort of a tragic ruin now. It's fascinating to visit. It's still eking out an existence. And I think it just, as noble as it was, it demonstrated how complex a question civilization and environment and habitation really is. And frankly, I think it was more about poetry than physics and thermodynamics and so forth. And it's still fantastic to visit, and still a very dedicated group of people keep it going and make absolutely beautiful cast bronze bells. They just make amazing bells. In fact, that's how the bills get paid, is by these beautiful bells that they make. So if you find yourself north of Phoenix, Arizona, go and see Arco Santi. Time passed, and the next big shock was the energy crisis. They turned the tap off for the oil supply, and suddenly we started thinking about the unlimited petrochemical resources that our House of Cards society had been resting on. And in the midst of that, as the oil-producing countries were kind of declaring economic dominance over the world, the Saudi oil minister at the time, Sheikh Yamani, made a very, very insightful statement, a quote I really love. He said, "The Stone Age didn't end for lack of stone, and the oil age will end long before the world runs out of oil." Right? The Stone Age didn't end because we ran out of stones. I absolutely love that idea. However, the crisis hit. Energy was the thing. It transformed lots of things in our society, including, automobile efficiency standards came in that the manufacturers resisted vociferously. And the same thing happened to buildings, right? Energy savings became the thing to deal with in buildings. So there's beautiful little Port Burwell elementary school, and the lovely big windows, and we did things like that, right? Which, yes, did save energy. Okay, we grant it. However, it destroyed the environment, for the people living in that building. And not only did it do that, but we realized it created this phenomenon called sick building syndrome, right? We were wrapping the buildings tight as a drum and trapping all the contaminants inside and forgetting that buildings are for people and not just about saving energy. So here's my next milestone, which is a publication of Ed Masria's Passive Solar Energy book in 1979. It was one of the first references that brought science to building technology and building design. And I don't know if you've ever seen it. It is fantastic. It translates these complex principles and ideas in terms that even architects can understand. Absolutely beautifully illustrated, and it is still a fantastic resource, something we still rely on regularly. Very, very practical, and showing you how achievable some of these systems and ideas are. So, sustainable design started to become a real thing, and it ran up against this question about development. And as human society expanded across the world and the world became more urban, the question was raised, is there a way of doing development in a sustainable way? Some people would argue that sustainable development is an oxymoron, right? I've heard somebody say that sustainable development is a term where the capitalists get the noun and the environmentalists are stuck with the adjective. So that's the question that the Brundtland Commission in 1987 was tasked to answer. Is there a way? And they suggest that there is a way of accommodating human development with environmental responsibility. And so they came up with the definition that is generally accepted for sustainable development, which is development that meets the needs of the present without compromising the ability of the future generations to meet their own needs, right? So we do things now with a view to how those things will affect the future. So, sustainability became really cool and fashionable in the 90s. And it became marketable. And in the 90s, we saw the rise of so-called greenwashing, where everything was put forward as green or having some kind of green aspect. So I love that cartoon of the fella painting the smokestacks green. And there's lots of examples all around us now. These are current ones. I love the Bic Eco shavers that you use a couple of times and throw them away. Everybody's been to a hotel bathroom that asks you to help save the planet without mentioning you're actually saving a whole lot of laundry expenses and so forth. And then the last one, I love the Hummer H3 billboard, thirsty for adventure, not gas, proudly only 20 miles per gallon on the highway. So the issue with greenwashing, or the opportunity that it took advantage of, was that there was no commonly accepted definition of what are we talking about when we talk about green things. And in the absence of that, it means sort of whatever you want it to mean. So I think that's really where LEED comes from. And it sounds like everybody knows what LEED is, but just in case you don't know the acronyms, and there's going to be a few of them this evening, LEED is Leadership in Energy and Environmental Design. And it is a consensus-based standard that was originally developed in the States in 1998. A broad cross-sectoral effort led by the U.S. Green Building Council to try to create a consensus. What are we talking about when we talking about green buildings? We adopted the Canadian standard in 2004. It was based on the U.S. standard version 2 with some adjustments for our climate. And then in 2010, there was a new standard that came out that we've been using pretty much since then, 2009. B, D, and C is for building design and construction as opposed to renovations and other applications. And the latest, greatest one is LEED version 4. It was actually issued in 2013 to some controversy. Both the strength and weakness of LEED is that it's a constantly elevating bar, right? Those of us who have used it will know that, what we did to achieve LEED Gold or whatever years ago only gets us to basic certification, if that, now. And so that's what makes LEED such a great standard, that it's constantly improving. But every time it does that, it's sort of past the comfort level of the industry often. And LEED version 4 in particular took a long time to come into popular use, and it has now been formally adopted, and that's what we're now using on our current work. So I put together a little slide to help give you a snapshot of how the LEED standard has evolved. So on the left is the first Canadian version, and the segments show you how the standard works. So the orange one is about sustainable sites. The sort of gray one is water. The yellow one is energy and atmosphere emissions, which obviously is a key thing for green buildings. The blue one is materials, and the green one is the key thing that we learned from the energy crisis and all those mistakes we made with buildings in the 70s. It's the indoor environment. It's remembering that buildings are for people, and the quality of the environment is a highly emphasized element of LEED. If you compare the graph on the left to the one in the middle, you'll notice a couple of interesting differences. And this reflects feedback from the industry on the application of the original standard. And there's a couple of things. First, you'll notice the orange wedge for site impacts got a lot bigger because buildings have tremendous impacts on their environment, from stormwater and siltation and all kinds of other effects that were given much more emphasis in the more recent standard. And you'll notice the yellow wedge got a lot bigger. Emphasizing energy, because I think that is something that our clients really look to as part of the reason for doing a green building. And as you increase the performance of a green building, it gets harder and harder to get the successively higher level of certification for energy. And in the original standard, there were silly things that you could do to get a credit. Instead of, using a much more sophisticated building control system to get another energy credit, you could have one room with the right kind of carpet and get a material and resource credit. So those sorts of equivalency issues were addressed in LEED 2009. The very observant in the audience will notice one subtle difference in the version 4 standard. By and large, it's similar to the 2009, but there's a light blue wedge. And what they've done is taken the site credit and put a lot more emphasis on where is the site, right? That blue wedge is about the location of the building. How well connected is it to existing infrastructure, intensification, transit, because it's one thing to have a green building sitting in the middle of a field far from any established development. It's another thing in terms of its impact to have it part of an infill site. So that's the big difference for LEED version 4, plus a whole lot of new acronyms. So the Green Building Council is a tremendously progressive and open organization. It makes all of this information available. And through the years, various new rating systems have been developed that address different parts of the building, so it's more customizable to the project that you're doing, as opposed to just big new buildings, which is the emphasis of the original standard, including houses and even neighborhoods. So lots of information available through the Green Building Council. Tom alluded to it, and there is another really great alternative rating system that we use as much as LEED. It's called Green Globes. It was actually originated in Canada, but it's become much more prevalent in the US. The General Services Administration that funds all federal buildings in the States considers Green Globes and LEED to be equivalent. And there's a lot we like about Green Globes. I won't dwell on it too much, but if people are interested afterwards, I can explain some of the specifics about it. The point is that it's organized in a very similar way to the LEED standard. You'll see those same criteria: site, energy, water, resources, emissions, and indoor environment, right? So it's founded on the same sort of structure. It uses the same reference standards from ASHRAE and CSA and other organizations. We just like it because it's a much more versatile, flexible tool. It fits with the way the design unfolds, gradually increasing the level of detail as you go through the design process. So we really like it. And it has a number of other advantages for a lot of clients, especially smaller projects and clients that are intimidated, frankly, by the onerous, if rigorous and reliable LEED standard. Green Globes is a lot more accessible. So that's, I think, how we got to where we are. And what I'd like to do now is talk about some of our recent work where we've tried to apply some of these ideas. There's a couple of Green Globes certified projects, a couple of LEED projects, and some from various different sectors in which we work, to try to show you at least how we have applied some of these green building principles. So the first one I'd like to talk about is the Community Wellness and Recreation Center in Komoka, designed by my talented partner, Allison Hannay. It's about 100,000 square feet, and it includes a YMCA, a gym, a fitness center, an indoor running track, a library, a twin pad arena. So a real community hub building, really, really fantastic project to be involved with. And it was intended to serve Komoka and that part of the county as a real social center. From a sustainable design point of view, it is quite an amazing building, if we don't say so ourselves. It's 80% more efficient than the comparable building built under the Model National Energy Code. A lot is thanks to a huge photovoltaic array on the roof of the arena. If you get far enough away from the building, you can see all the PV panels up there. It also employs, for making ice, an eco-chiller system that, rather than rejecting heat to the environment, uses it to heat the building, including in-floor heating systems and dressing rooms and so forth. So it displaces a lot of fossil fuel energy that we would otherwise have had to use. And I think one of the coolest things about this building is the use of glass. It is a tremendously bright and open building. Lots of different glazing systems were used for different applications, including in the main rink itself. You can skate in the rink with the lights off on a sunny day. It is absolutely gorgeous. All credit to Allison. Here's another one of Allison's projects. This is Clare Hall and the Mercado at Brescia University College, which we did in partnership with Perkins & Will. It's another Green Globes project. This one is 5 Green Globes certified, which is equivalent to LEED Platinum, so very, very high performance building. It's 131,000 square feet. It includes a 300-bed student residence and a large dining pavilion and a beautiful marché. You know, if you've been to Movenpick, that's the style of the food service. Really, really fantastic. And it is the social hub for the Brescia campus, both for kids that are living on campus as well as those coming for classes. From a sustainability point of view, it had very, very high achievement of the energy targets that Green Globe sets out. Here's an acronym. It was the largest VRF system in Canada at the time. VRF is a very versatile and high efficiency heating, ventilation, and air conditioning system. It stands for variable refrigerant flow. It's essentially a heat pump system, but instead of using water lines, it uses refrigerant lines, so it's a lot more compact and extremely energy efficient. And compactness is sort of a theme of that design and of green buildings in general, that a great way to reduce a building's impact is not make it too big, right? So Brescia has beautifully designed very small rooms and generous common spaces. So more of the emphasis was placed on the common rooms. And the indoor environment is also extremely good. That slide there is the main lounge space, and that's a radiant heating system in the floor. So when I've taken people on tours, we always take our shoes off and feel how nice and cozy the floor is. So really encourage that space to be used. This is one of my projects. This is the village at University Gates. It's a project for our client Schlegel Villages, who are a leading provider of elder care and accommodation in Ontario. This is their project that's actually on the University of Waterloo campus, and that the part of the building that you see in that slide is the Research Institute for Aging, which they founded there at Waterloo. And it's an example of a lot of the long-term care projects we do and the new generation of these buildings in Ontario, which is trying to change the paradigm of nursing homes and emphasizing socialization and interaction with the community. And the Schlegels really do a great job of doing that, not only through the design of the building, but of the programming that goes into them. And a fun fact, long-term care is the only type of building I know of where there's a funding incentive for LEED certification. There isn't a funding, it's not mandatory, but if you achieve LEED certification, there is a funding incentive for long-term care facilities. That's usually a question from clients, when we talk about LEED, well, what's the funding for it? Well, it's voluntary and there usually isn't funding, except in long-term care facilities. So its performance is also good. It's a LEED Gold certified project, so it performs much better than the building code or the energy code standard. It has a large PV array on the roof, extremely low water use. You can imagine these kind of buildings, they go through a lot of water, so that was something that was emphasized here. And very, very high quality indoor environment. That bottom right corner is the slide, it's Main Street. That's what you see when you walk into the long-term care home. You don't see nurses or the typical accoutrements of these sorts of environments. It's a social space. The community is invited to be part of it. It's hard to take a picture of that area without people in it. And it's tricky to accomplish that in these building types because the funding is quite tight. And the ministry's standards for ventilation and illumination are somewhat at odds with what we're trying to accomplish for energy savings. So they are fascinating projects to be involved with. The last project of ours that I wanted to highlight is one of our more recent ones, the Western Engineering 3C+. So you're going to be able to answer a trivia question about what 3C+ stands for. It's Connect, Create, and Collaborate. The Dean of Engineering christened it with that name, and because it's trying to provide space that was missing at Engineering and Western. The engineering complex at Western had lots of fantastic lab space, classrooms in very highly programmed specific use types of areas. This building complements those by having, especially on the first two floors, collaborative space, non-programmed and rooms not associated with a particular discipline, so they can be organized by projects across discipline. That's the principle behind this building. And it's targeting LEED Platinum. We have to say targeting because you don't get your LEED certification until your building's done. I like to say the Green Building Council doesn't take our word for what we're going to do. Our certification's based on what we can prove we've done. So once the project is finished, as the other practitioners in the room will know, you package up all the material, you submit it to the Green Building Council, and it usually takes about 6 months for a large building for the certification to come back. And we're confident that this will exceed the requirements for Platinum, but we won't know until quite a while after the building is finished. So it performs very well relative to the energy code. It also has a large photovoltaic array on the roof. Really, really low water use. It uses almost no drinking water and for flushing toilets, and all of the stormwater that hits the building, none of it goes into the municipal storm system. There's a huge rainwater harvesting system, and that was something that they really emphasized as part of the program too. The civil engineering program emphasized that aspect of this design. Lighting and daylighting is also very important in this building. One of the trickiest things about it, it faces Western Road, so that long exposure faces west. And that's a very, very tricky thing to handle from an occupancy point of view, from an energy point of view, so a lot of strategies were employed to address that. The top photo is photochromatic glass that can be adjusted, and the demonstrations anyway, and this is how it's intended to work, are connected to both time and date, so the glass knows what time of year it is and when the sun rises and sets, and weather. So the glass also knows whether it's going to be a sunny day or not. So nobody has to look after it. It will change the exposure to maintain the indoor conditions that are programmed. It can be override. Some engineering kid is going to learn how to hack it, so don't be surprised if the glass is, going crazy when you drive by. So a lot of those sorts of things are there to see. And at the same time, there was a budget, and while the engineering school wanted to achieve LEED Platinum, the university made it very clear that they had to do that on their own dime. That there was funding for the project, and Western builds very, very good quality buildings, whether they're LEED certified or not. So the difference between what would have otherwise been funded and what we are doing had to be made up by the engineering school, and they committed to that, and that's where the fundraising has come from. And you can see the math there in that chart. The lighting and space heating savings are the most significant ones, but also cooling is very significant. They're so-called chilled beams. So instead of a room like this that has diffusers, right? So if it gets too hot, those poor diffusers have to try to push pressurized air down here to where the human beings are. Chilled beams work on very, very, very low velocity and tempering the air very, very gradually so that you're not aware of drafts, and it's an extremely energy efficient way to do, although tricky, have to be careful about condensation. And the other bottom slides are just some images from the computer model. There's 3D navigable models on Western Engineering site, so if you want to take a virtual tour through the building, you can help yourself. Okay, so the future. There's two quotes about the future that I love. The first one is attributed to the physicist Niels Bohr. He says, "Prediction is very difficult, especially about the future." I am going to make some predictions and stick my neck out about where I think we're going with some of these things, notwithstanding Dr. Bohr's caution. My very favorite quote about the future is from the sci-fi author William Gibson. He says, "The future is already here. It's just unevenly distributed." And I think that's very true. I think there's so much happening. I'm hoping to share some of these things with you here today that are it's just concentrated, amazing stuff happening that not all of us have found out about yet. So, what do I think is going to happen? Well, let's start with the rating systems, right? We're still going to continue to see LEED and green globes in active use, and they're going to continue to improve, and set higher and higher standards. But there are much, much higher objectives in front of us. The Canada Green Building Council has just come up with its zero carbon building standard for net zero carbon, net zero energy. So not just, beating the model energy code, but having no net energy or even net positive energy. There are two really, really high standards. One is the WELL building standard, and one is the Living Building Challenge. And so that, if my cursor will come to life here for you. There we go. The WELL building standard are the little dots here. There are 7 criteria, and they include the conventional things you might associate with buildings, but also nourishment and mental well-being. And as we struggle to measure other aspects of the LEED standards that we work with, it raises interesting questions about how do we really measure some of these things, and yet they're extremely important. The Living Building Challenge has these petals. They're a little more recognizable. I don't know if you can read the labels there, but around the petal it's site, materials, energy, indoor air quality, water, and health and beauty and inspiration, right? It's starting to take that point I made earlier about reminding us that buildings are for people and putting that as the most important thing, right? That let's think about the wellness aspects of the environments we're creating, and then let's think about all the environmental and energy things that we can do. So those are very, very lofty standards. They have not been well picked up so far yet. There's only a handful of projects around the world that are following those standards, but I think it's going to influence what the rest of the industry is doing. The last two are very important ones that we are using. Passive House is a standard from Europe that harkens back to those passive energy principles in Ed Mazaria's book and reminds us, you know what, let's try to keep it simple. Let's try to design as good a box as we can. Very good windows, very good insulation. You know, let's make the envelope and take advantage of the exposure that a building has inherently before we have to add lots of fancy, complicated technology to it. That's sort of the gist behind Passive House. And while it was, and it still is addressed at residential buildings and wood frame construction, it's starting to be used in larger and larger buildings now. And the last one is another connection to Ed Mazaria. Architecture 2030 is a movement, an international movement that he started a few years ago. And those are the bar graphs there in the bottom right that set very measurable and specific targets for us to reduce to zero the net energy use of our buildings by 2030. So all of those things, like LEED and Green Globes, are voluntary, right? And it's been up to motivated clients and organizations and advocacy from the consulting community whether people use them or not. That is changing. We are at the dawn of mandatory benchmarking, okay? That is the bill passed in New York State for the city of New York for it to become the first jurisdiction, at least in the States, to require publicly posted building energy grades. So all the big buildings, including Mr. Trump's, will have a letter grade posted on the front door from A to F, okay, based on their energy performance. And what does that mean? Like, who cares? It's a piece of paper on the front door of the building. But I think people are going to notice that. You know, if you're looking at an apartment in New York for God knows what you have to pay for it, I think you're going to notice, is this an A building or is this a D building, right? It's very, very simple, vivid notice. And it's all tied into Energy Star's portfolio manager. So Energy Star, just like your washing machine, you can get Energy Star ratings for buildings now. The US has a database of thousands and thousands of buildings, so your building can be evaluated on a scale with the typical buildings in the rest of the country. And that's how these ratings in New York are going to work. That's coming to Ontario. The provincial government passed legislation last year that as of July 1st this year, every building over 25,000 square meters, 250,000 square feet, so these are pretty big buildings, they have to report their energy use annually. And then next year, buildings over 10,000 square meters, the year after, buildings over 5,000 square meters. So that's going to be most large buildings. They have to report their annual energy use every year. Now, they're not getting a letter grade. I think part of this is building our database about, so how are our buildings performing? What is the standard that we're going to be compared to? And eventually you might see some kind of a posting. But again, it's tied into the Energy Star portfolio. So that is not only the future, that's here, it's coming. The next big thing on the agenda, in fact, a very important deadline passed at midnight. The federal government has announced a big carbon pricing, cap and trade system for Canada. And all the provinces have signed on, except for Saskatchewan. They're going it alone. And it's a very, very controversial thing. It has huge economic impacts depending on the nature of the provincial economies. And what's proposed is a price of $10 a ton starting this year. And it's going to go up by $10 a ton every year to $50 a ton in 2020. So what does that mean? $10 a ton is going to add couple of cents per liter of gasoline or diesel fuel and a little less than 2 cents per liter of propane. So it's not huge, but it does add up. And if the provinces that have signed on to the program, it's, I think, a very intelligently designed program on the part of the federal government because it gives leeway to the provinces to adapt the carbon pricing scheme that they want to use to their own situation. And so Ontario is targeting some of the big issues, the electrical energy importers, fuel suppliers, and then large facilities that emit more than 25,000 tons of CO2 a year. So that, like Western, would be captured. The hospitals here would be part of this, this initial targeting group. And I know they're starting to think about, holy cow, what are we going to do about this? So these things they're on the very close side of the horizon. These, we're going from a sort of this voluntary, don't we feel good and aren't we proud that we've got a green building and have voluntarily certified under the various standards, to now having to benchmark ourselves, to now having to pay and trade and keep track of our carbon emissions. So the world is changing. And how can we do it? I'm reminded of the reaction from the auto industry, right? And the energy crisis, that, oh my God, how are we ever going to meet those fuel efficiency requirements? The consumers will not go for it, it'll never work. Well, guess what? The fuel efficiency of our automobiles is just massively better than it was once upon a time. And I think the same thing is going to eventually happen with our buildings. And it would be great if only we could take advantage of that dream of fusion energy. It's been this lofty goal of unlimited free power, that has been researched for literally decades. And it's always 10 years away, this dream of fusion energy. And it would be particularly great if we could put a fusion reactor at a safe distance away, say about 150 million kilometers. Guess what? We already have one, right? That's the Earth to scale relative to the sun. It is such an unlimited source of energy that we sort of fail to appreciate it. And I think gradually we're starting to. 1 hour of sunlight is equivalent to 1 year of human energy consumption. That's not just electricity, that's everything. Transportation, heating, everything. 1 hour of sunlight. There's a great little map, and you can barely see the dots on the map of the Earth, but that's the point. With current photovoltaic technology, like forget all the new developments that are happening, current photovoltaic technology, we could power all human energy requirements in 2030 with 0.3% of the Earth's surface. So if you look at that map, there's a big square of panels, and somewhere in the Arizona desert, in the Sahara, in the Gobi Desert, there's lots of places on Earth where hypothetically you could build like 100 square kilometers of panels and generate all of the Earth's power requirements using our current technology. I just think that is incredible. Yes, how do we get it from those little dots to where the rest of us are living? But those kinds of solutions are being worked on, and obviously it's not all in one spot. It doesn't need to be. That bottom right graph is a famous graph from the National Renewable Energy Lab that tracks all the technologies for solar photovoltaics. The polycrystalline panels that we all use right now is just one of those little lines. There's dozens and dozens of other kinds of technologies that are being actively developed, and that graph is showing how their efficiency is improving over the last few years. So to try to convince you even more that the solar revolution is here, there's a really great resource from IRENA, the International Renewable Energy Agency. You can go online and you can create these charts yourself by selecting different parts of the world and different technologies. So that's what I did. The top right chart takes those technologies, the thin film solar and silicon and all the other technologies, and tracks them. This is only going back to 2011. maybe not even that. Yeah, 2011. And you can see how rapidly those prices have fallen. That gray band is the cost of fossil fuel energy, right? So they're already well within the cost of developing and operating fossil fuel energy. And you can see some of them are even poking below the cost of fossil fuel energy. There's a point in the US now, south of which you don't need any incentive to put solar PV on your house. There's no program necessary. It just makes sense. If you've got a south-facing roof surface and it's not shaded by anybody, it pays for itself, literally. And that rising, or the lowering cost of the technology, combined with rapidly increasing manufacturing capacity, there's so much investment in this sector and so many things happening simultaneously, is accelerating the deployment. So the bottom right slide is a graph for North America solar. And that's 2005 on the far left and 2016. And you can see it's accelerating. It's an exponentially increasing trend. So you can play around with these graphs yourself if you go to the IRENA site. So not only is the solar revolution going to help us achieve these lofty goals of these very, very high standards we're going to see in our work, but there's also amazing design tools available. These are a couple that we use. Saphera is an energy simulator that takes our building model and tells us how much energy it's going to use. It can quickly tell us, the benefits of different configurations. It could also tell us about daylighting and views, and run many, many iterations without having to get the energy consultant involved and waiting 2 weeks for their results. The other tool we use a lot is the Athena Impact Estimator. It helps track life cycle impacts. So rather than only concentrating on operating energy impacts, which is what most people think about, we can look at systems and how we make the building in the first place, and look at its overall life cycle. How long is the building going to last? What are the energy impacts of replacing the materials that we've used over the life of the building? So these tools are really, really helping us understand more about the choices that we're recommending. There's a really exciting other development in design tools. This is some information from the most recent issue of the American Institute of Architects magazine, Architect, this month. Under the title Generative Design, there's a firm called The Living in New York City, founded by David Benjamin, and it's using machine learning to give us even greater insight into the designs we're creating. This is Autodesk's new office in Toronto, and the parameters that were entered into this software around that hexagon include individual preference for view, who the relationship in the office needs to be close to, what kind of workspace do they need, and puts these parameters into an algorithm that generates literally hundreds and hundreds of options, and then filters those options according to the client's preference and emphasis, and gives you some insight. So I don't think it's going to replace us, hopefully, too soon, but it just gives us much, much more insight into what the possibilities. If the client is saying this is important, that's important, it helps us evaluate those things much more objectively. You can see the resulting office space. And obviously, that kind of technology will also greatly improve our capability to analyze things from a sustainable design and energy use point of view. So the AI is entering our office space. There's also some cool new materials that we have as part of our palette. One of the most interesting ones, I don't even know exactly how to say it. I think it's CO2-ncrete. And it's a project at UCLA that has won an X Prize for carbon capture. The idea is, well, if there's too much carbon dioxide in the universe, in the atmosphere, why can't we just directly capture it, like just pull it out and do something with it? So this technology does that with industrial smokestack emissions, which are very, very high concentrations of CO2. It sucks that out and actually makes concrete from that material. Quite an amazing idea. Another acronym many of you may be familiar with is BIPV, Building Integrated Photovoltaics. So The idea behind these materials is that we don't build our building and then, go and buy panels that we have to put on top of the roof and prevent from blowing away and so forth. The photovoltaic properties are part of the materials themselves. So Elon Musk's company Solar City, you can buy some nice Solar City shingles for your roof that generate power, so you don't have to put a regular roof on, you just buy the shingles, they are the roof. And I see a huge development in flat roof membranes that have photovoltaic properties inherent in them. I predict that the clients we're working for right now, who are putting flat roofs on their big buildings, by the time it comes that they have to replace those roofs in 20 or 30 years, it'll just be a tick box on the order form for the new membrane. Would you like the photovoltaic membrane? Yes, please. And that has tremendous implications for addressing that capacity issue. Where are we going to get the PV capacity from? And lastly, really interesting technology is photovoltaic windows. We have the adjustable glass, the photochromatic glass that I showed you we're using at Western, that shades itself, it doesn't generate power. The new technology is going to also be able to generate power. There's also new ways of building. Prefabrication, is something, frankly, we have seen subtly changing in our work. It doesn't meet the casual observer as being very obvious, but more and more of our buildings are prefabricated, much more than you might think. Everything from pre-cut steel studs, right, rather than the guy coming with the chop saw and cutting his studs on site. The floors are pretty flat, so all the studs are about the same size, so they just order them all pre-cut, and it tremendously eliminates waste on the site. But more and more components are going to be prefabricated. This is a beautiful project by Pat Cow Architects. It's skating shelters that are just these crazy forms in Winnipeg. This is all prefabricated, highly controlled environment. Didn't have to be nailed together outside in the elements in Winnipeg. 3D printing is in its infancy. Lots of people are playing with 3D printers at home right now. The Chinese are playing with 3D printers for buildings. And as you can see in that image, the results so far are somewhat uninspiring. However, stay tuned. That project is a building by Watt G, a firm in New York, that won a competition for a 3D prototype house that they are now starting to test using composite materials. So if you can sketch it, you'll be able to 3D print it. And pretty cool opportunities that opens up. And the last thing are robots. Robots are starting to enter the construction site. That is the TieBot. Coming to a site near you. One of the most tedious jobs in a construction site is tying the rebar together. You got to take a little piece of wire and you tie the rebar together, and go along and you tie the next one. And so a robot can do that now. It can see where it is. It knows where it is in the building. It knows exactly what it's looking at. It can check to see if the rebar isn't what is supposed to be there, and just one guy can supervise the whole thing. The TieBot. The last couple of slides, I want to try to bring this back to together, and the city. And how do all of these things contribute ultimately to making better cities? We are becoming an urban civilization. And what we do with our cities is going to determine a lot about the fate of our future society. I've heard it said that cities are the greenest things humans do. And I really think that's true. A couple of examples here. The top two images on the right are the project you may have heard about at Waterfront Toronto. This was a competition awarded to Sidewalk Labs. I don't know if you know who Sidewalk Labs is, but Sidewalk Labs is owned by Alphabet. And one of Alphabet's divisions is Google. Right? So Alphabet is the parent company. They own Google. They also own Sidewalk Labs, which is their development company. So they are proposing to take this former industrial land very, very close to downtown Toronto and transform it into a very, very advanced so-called smart community. And not without controversy. There has been some reaction about Big Brother coming to Canada to show us how we're supposed to build our cities, but still extremely exciting, extremely ambitious, and the city is very, very much a partner at the table. with the project. The bottom two images are one of the most exciting things close to home. This is the Sifton's West 5 development. Many of us in this room are involved with that project. Extremely ambitious. They have set a very straightforward goal of being net zero energy as a community. So when the whole thing is finished, and the interaction between the commercial and residential and other uses will help them over the course of the year generate as much energy as that community consumes. It's a very straightforward, easy to measure, and ambitious goal. At the same time as doing that, they want to create an amazing pedestrian and human environment. So a really, really exciting project here, close to home. Very, very close to home. These grand initiatives are exciting, but the community scale initiatives also make a big difference too. So here are a few of the fun things we've been involved with over the years. We're big supporters of Reforest London, and you can be too. That top picture is a group of us after one of our tree planting sessions with our puppy dogs and some of the kids and so forth. It's really fun. The bottom right corner is our street. Our neighborhood is participating in Project Neutral. Your neighborhood can get involved as well. It's about tracking energy use and carbon footprints and how we compare to the rest of the city and our neighbors. And it sets up a friendly competition between groups of neighbors, sort of two sides of the street. Fortunately, we're on the green side of the street, so we can turn our noses up at the red guys on the red side of the street because they're not as efficient as us. And it's partly about providing information and connecting your behavior to how your energy is affected by that behavior, and helping you to compare. Okay, well, my house is a lot like the house across the street. What am I doing differently than them? And then the last one is one of the most interesting things I think that's going to be happening here. There's an organization called the London Environmental Network, and they are starting to develop a Made in London carbon tracking program that we can all participate in. Our office, that's our carbon tracking records from 2007 to 2013, those graphs there. And we did that through Zero Footprint a few years ago, but it was very cumbersome. It was directed at very, very large organizations and was really awkward for us to take advantage of. And that's what the London Environmental Network wants to try to do. All of us can track our carbon, and a little bit like our neighbors on the other side of the streets, maybe the architects can challenge the engineers to see who has the most energy efficient office space as a community. So all of these things are about making measurable progress and having some fun doing it. I like to finish with some recommended reading. This is my current favorite list of recommendations. And each of them brings a different perspective to these issues I've been talking about. And I will post this for those who are interested on our website, and I'll give you the link at the end of the session so you don't need to write this stuff down if you're interested. But I do want to put in a plug. This is Stuart Brand's recent book. Remember Stuart Brand? He was the first slide, Whole Earth Catalog, 78 years old, still at it. An amazing guy. He wrote this incredibly insightful book for the next generation. And it did look back and was critical about some of the things he was part of doing that turned out not to be such a great idea. And makes advice. He reminds us we are not in the 60s anymore. And we need to use the tools that are available for us now to make the kind of progress that we're going to need to make over the near future. So if I had to recommend one thing to read, that would be it. So that's pretty well it. As I said, I'll put the presentation up on our website, cornerstonearchitecture.ca. It'll be under the Resources tab, so Cornerstone Architecture Resources. And before wrapping up, I do want to say thanks to my wonderful partner, Allison, for being part of this great adventure. Where is Allison? There she is. She's right at the back. And many of the people from the office are here. We're just a wonderful team of people that help make all this happen. And the client organizations, we've been privileged to work with a lot of great client organizations that provide the kind of motivation and inspiration that's led to this stuff. So I hope this has been helpful. I hope it's been insightful. I hope you have some enthusiasm for what's exciting and what the possibilities are going to be for our industry in the very near future. Thank you very much.